Okay, so in this video we are moving on to what we're going to call interest graphs. And through this video I'm going to take you through how we can draw some for simple interest, which we've encountered in previous topics, as well as compound interest graphs in the next video. So this is going to require us to pull together different things that we've learned from different topics. The first is actually remembering what the simple interest formula is. And just for a little recap, this is that the interest equals the principal times the rate times the number of years. So differently to the compound interest formula, with our simple interest, it's not interest on top of interest, it's just the same interest every year for a certain n number of years. So this guy's kind of important here. But we're looking at this one example question for this video, which is that we have a period of 10 years. Over 10 years, $1,000 is invested at 8% per annum. So here we've got our, I'll write it underneath, we've got our N here, our principal here, the initial amount of money, and we've got the rate here. So first of all, let's just substitute everything in here, and we're going to think about how we can apply this to a graph. Now, what we're going to do here, because with all of these graphs for simple interest and compound interest, we are eventually going to be graphing. The two variables are going to be our n against our I. So the second part of this question, this will become more clear later, but basically we're going to take these bits of information and we're actually going to temporarily just ignore this thing over here. We're going to leave everything in terms of the number of years. And we're going to see why this matters when we actually start to draw the diagram. So let's take the P and the R and substitute those into this formula that we had. So we have I equals 1,000, that's our principal, times our rate, 0.08. I've just written the percentage as a decimal, and we're going to times that by n. Because this part here is the bit that stays the same regardless. The interest we get is going to change depending on the number of years we're allowing our investment to go over. So that's why the n actually stays as it is, because the interest depends on the number of years. So if we write this in, timesing through 1,000 by 0.08 is going to give us 80 times n. And we remember with algebra, when we have these letters, we're just going to leave the number next to the letter. But as with a lot of things in algebra, this implies a multiplication sign. So this gives us what we remember as a linear relationship. One variable, I, changes in a linear way based on the number of years. This is the same as if we wrote, for example, y equals 80x. That's from our linear relationship to y equals mx plus b. But here, the y-intercept is going to be 0, which we'll see in a second. So this is when we end up graphing it and make our table of values and everything, this is actually going to give us a straight line. We're anticipating that based on how our formula that we came up with looks. It resembles something like this on the right-hand side. Okay, so what we're going to do, we're going to substitute in all of these different values of n into my formula here. So the first one, I'm going to, at 0 years, this makes sense, we're going to get 0 interest because we haven't actually given this time to accrue. So I'm going to graph that in here. If we substitute 1 in for the n, also you can pause this video and do this on your, like by yourselves if you'd like. I'm just going to go through this a little bit quicker. So at 1 year, this is going to be 80 times 1, which is going to give us about 80. So that'll be, I don't know, around here. 2 is going to give us 160. About here, let's say. And going through, I'll just jump to 4. 4 gives us 320. So 4 is going to give us 300s there, plus another 20, maybe up here. Let's actually get rid of this guy. And at 8 years, we're going to get 640. So I'm going to get my 8, going up to about 640. Let's say that's around here. Pen's deciding to mess up a little bit. Hopefully you can see that dot. And at 10 years, we're going to have 800. So I'm going to line up my 800 with my 10 here. And when I eventually go through and draw this, we're going to see actually a straight line. So let's do this in blue, connecting this to this. I get a linear relationship. Obviously, this is a little bit weird based on the points that I have, but I have actually drawn the graph of I equals, I'm still in shapes, I equals 80n. Okay, what this gives us then is a way to estimate interest for different things. So say we wanted to find the amount of interest we would get at 7.5 years. So what we're going to do, like with other things in linear relationships, is we'll find 7.5 in my years, that's down here, and I'll draw a little dotted line up to where I hit my graph. That's this point here, and then I draw across. So we can estimate that we're going to get $600 in interest if this is left here for 7.5 years. So we're pulling together the different concepts. We have what we remember from simple interest, this I equals P times R times N. And then when we get it, substitute in the things, leaving my interest and my number of years, which is the thing that changes the interest. These are our two variables, as we've talked about before. We get a linear relationship or some other kind of graphical relationship. That's how we can draw these graphs and use them to answer questions. Thank you so much for watching, and I'll see you next time.